Okay, so we have 4 questions here that came in the 2024 GCE Science Paper 1. And let's see how many you can answer here. The first question says, the diagram shows a simple pendulum that swings from A to B to C and back to B in just 0.75 seconds. So, what is the period of the pendulum? Before I even go anywhere, period of the pendulum is given by time taken over the number of complete oscillations. We know that the time taken is 0.75, but where the problem is how to find the n. How do we find n? When you move from A direct to C, it makes half oscillations. So you have half oscillation plus. When you move from C to B alone, that means any movement, whether A to B or B to C only, or C to B or B to A only, that is a quarter, 1/4, which will give us 3/4. These are the number of oscillations. So now we go. What is 4 into 3? It's 0.75. That means period is equal to 0.75 as time taken, seconds, over the number of complete oscillations is 0.75 as well, which will give us 1 second. So our answer here was C. Then we move on to question 2. It says a person fell from a transmitter of height 80 meters. Ignoring air resistance, calculate the time for the person to hit the ground. Now, this is motion under the influence of gravity. If someone is falling, through a height of 80 meters, we know that the acceleration due to gravity is 10 meters per second squared. We are going to use the equation of motion number 2, which is just that the height is just equal to let me state it from the beginning. Initial velocity times time plus half acceleration, then time squared. So we have height is 80. Remember that it's falling from a height. That means this person was falling from rest. So initial velocity is 0. So here to be 0. We have half. Acceleration due to gravity is 10. So it's a time squared. So 2 into 10 is 5. 5 into, so I divide by 5 because what you have here is just 5. So that's the one thing that we are meaning with now. That means we have to divide there. This will give me 16 is equal to t squared. So I find the square root. So t is 4 seconds, which is A. You see how easy it is, right? And question 3 says an astronaut. So let me just get rid of this part here. We read the question properly. An astronaut can jump through a great vertical distance on the moon than on Earth. This is because the gravitational field strength is, they are saying, an astronaut can jump through a greater vertical distance on the moon than on Earth. So they are saying if this is a moon and this is the Earth, they are saying the person can jump a higher distance as compared to that on Earth. So assume this is the distance and this is also the distance. So the person can jump this distance on Earth, but can jump this distance on the moon. The question is why? So they are saying this is because the gravitational field strength is what? A is constant on Earth. Is the gravitational field constant on Earth alone? No. It's also constant on the moon. On the moon it's about 1.6, on Earth it's about 10. So this one is out. B is greater on the moon. No. On the moon it's about 1.6, on Earth it's about 10. So it's out. C is less on the moon. Yes, look at the moon, 1.6. Look at on Earth, it's 10. So the answer is C. You don't even have to go to D. They are not the same. Question 4. Question 4 says, A 100 uniform beam is balanced when pivoted at X. A mass of 200 rests on the beam as shown. Alright. What is the mass of the beam? Now, what we need to know that the mass of this beam is actually at the center. Now, this is 100 centimeters, right? That means the center should be 50. So we need to locate 50 from here to here. It's 40. So 50 is somewhere here. This is where the mass is. Let's call it MB, the mass of the beam. At where? At 50 centimeters. Because the mass of the entire beam is concentrated at the center. I'm just trying to assume that this is the center, okay? So we are going to take clockwise moment and anti-clockwise moments. So we have this guy here moving in the direction, while the mass is moving in that direction. So the moment of this and its distance, okay, because they are saying it's pivoted at X. So we eventually just have to know the distance from the pivot. Alright, just have to do what? To know the distance from the pivot. So from there to there is 20. Okay, so we have 20. Now this is 20 centimeters. It's okay whether you convert it or not. There is no problem. So we have 200 grams multiplied by the distance from the pivot is 200 is 20. So we're using the principle of moments now, which is this. That let me do this. The sum of anti-clockwise moments and is equal to the sum of clockwise moments. And clockwise are here, so we have 200 grams multiplied by 20 is equal to this is 20 centimeters, by the way, is equal to clockwise moment. We have the mass of the beam MB. Now the distance of the distance of this from the pivot, we are looking for that distance, not 50. So if this is 10, so if this is 40, right, to reach 50 this must be 10. So 10 plus 20 plus 10 plus 50 will give you what? 100. So we are using 10 there, over 10 over 10. So the mass of the beam is in fact 400 grams. As you can see here, our answer is C. So thank you so much. These were the first 4 questions in the science paper 1, which is physics, and I hope that you enjoyed them. Subscribe for more.